Um, I was planning to give a demo, and unfortunately my computer displays everything green. So I think usually when you watch one of these talks, there's the sort of a bit of suspense for both the speaker of the audience, will the demo work? And I'm afraid I have to put you out of that suspense right now. The demo will not work, because it's failed already. But hopefully you'll find the slides interesting as well. Slightly less potential for disaster with the slides. So what I'm going to be talking about is Enterprise OSGi. It's something I'm really passionate about. It can make your programming so much more effective, so much more clean. If I ruled the world, everybody would be using OSGi. Let me give you a bit of background about myself, first of all. I'm Holly Cummins. You can find me on Twitter. I'm a developer with IBM. I've been with IBM for 11 years now. I've done a lot of things with IBM. What I'm working on right now is I'm a developer on the WebSphere Liberty profile. I've also done a lot of work on OSGi applications and the OSGi applications programming model, which you can also find in the Liberty profile. In a former life as well, I was at the other end of the stack, and I did a lot of work with Java performance and garbage collection. I also have some involvements outside IBM, so I'm a committer on the Apache Aries project, which again is an OSGi project. So do I know what I'm talking about? Well, probably not, but some people do disagree. So I've got a book coming out on Enterprise OSGi in action. Physical copies aren't out yet. I've discovered that books are a bit like software. You think you're really, really close, and then you think you're really, really close, and then about a year later, you're really, really, really close. But now it really, really is close. So it's in the sort of the final stages of typesetting and proofreading. Manning do a quite nice agile process as well. So you can get the books as an early access, and then you can give feedback to the authors. So if you absolutely want to rush out and you can't wait for the paper copy, you can go and get an early access online. But let me start with a bit of background about why Enterprise OSGi is even a thing, and why it's new and exciting and interesting. I should say as well, I had tonsillitis last week, so if I die halfway through the presentation, it won't be unexpected. Be a bit sad, though. So how did we get here? Well, a long time ago, in a galaxy far, far away, maybe 15 years ago, we had Java, and we said, well, this is really good, but I'd like to do business with this. I'd like to do the web with this. I'd like to do data. I don't want to reinvent all of these things. I need some sort of programming model. I need some sort of framework that can do this. So Java EE was invented. Sorry, I think this might go badly wrong if I try and drink. So Java EE was absolutely brilliant for the web. It was brilliant for data. But it didn't really have much to say on modularity, and it definitely wasn't dynamic. So, at about the same time, in a different galaxy, there was another new hope, and this was OSGi. And it was born around the same time, and OSGi was originally invented for embedded systems. These tiny little systems, they needed something where you could take parts of the system away because it was actually a system that was physically changing. It was maybe something like a set-top box where devices were coming and going. It needed to be really small because it was an embedded system. So it was superb at modularity. It was superb at dynamism. But it didn't really have much to say about how you would access your database, because this was a set-top box. And it didn't have much to say on how you would expose your application to the web, because again, this is an embedded device. And for a while, that worked pretty well. You know, if you were doing the enterprise, you could do JEE. If you were doing a set-top box, you could use OSGi. And I think for a lot of us, sort of more on the JEE side, we didn't really hear much about OSGi, but it actually has been incredibly successful. There's this sort of embedded world that's been going on for 15 years, and they've been using OSGi for all sorts of things. So for example, if you have a BMW 5 Series, and you look under the bonnet, inside that 5 Series is OSGi, which I just love. If you have a set-top box, there's probably OSGi inside that set-top box. If you have a web server, there's also OSGi inside that web server. But you, as a user of that web server, maybe aren't using OSGi. So for a while, this worked pretty well. But lately, these two worlds have been coming together a bit more. And this is where we start to have a problem, because as a user, traditionally you had a choice. You could say, well, I'm JEE, so that's fine. I'll use JEE. OSGi is not really going to work for me. Or you could say, I'm a BMW 5 Series. I don't really need a web server. I'll stick with OSGi. So you had, New Hope 1 and New Hope 2, and you had to take your New Hope and stick to it. But now we're getting this kind of converged place. The applications that we're running on our web servers are so big that it's not good enough anymore to say, oh, well, modularity, dynamism, they would have been nice to have, but oh, well. We need this modularity because we can't actually control our applications anymore. We don't know what's in them. They're massive. And on the embedded spaces as well, things are changing a little bit. So it's no longer the case that we put our embedded device away and then we never talk to it again. Because now, actually, maybe we do want to be running a web server on our embedded device. Maybe we do want our BMW 5 Series to have a web client in it. So what do we do? Well, this is where Enterprise OSGi comes in. So as the name suggests, Enterprise OSGi really does just combine these two programming models so that you can have the best of, the modularity, that, everything else that you might want to take from the OSGi world. But you don't have to give up the stuff like the nice programming model for the web. You don't have to give up your wars. You don't have to give up your servlets. Enterprise OSGi, I guess I keep talking about it as new, but actually it's been around since 2010. So in the software engineering world, that's probably not new anymore, is it really? The aim of Enterprise OSGi, like I said, it's to bring these enterprise programming models into the OSGi world so that you can take advantage of OSGi without losing all the stuff that the programming models that you're used to. It's been pretty widely supported so far, so not all of them, but most of the application servers that you might be using probably have Enterprise OSGi support. So WebSphere has it. Glassfish have something that they call hybrid applications, which is the same idea. JBoss have it. There's also quite a few open source servers. So there's Virgo, for example. Geronimo has it. You can roll your own stack starting from the ground up with something like Apache Carafe. And that will have Enterprise OSGi as well. So what Enterprise OSGi gives you is it gives you web applications. You can use your databases. You can use the JPA programming model. You can have transactions, declarative transactions, because, of course, you really don't want to be writing your own transactions. You can have remoting as well. So this allows you to distribute your application across a few servers, which may come in handy. And at this point, some of you may be thinking, there's actually nothing new here. All we've got so far is all the programming models that you're used to from JEE, but with a little bit of OSGi thrown in. And so why would you even bother? If they work in JEE, why do you need the OSGi bit? Well, it's all about the modularity. So we often say that OSGi enables modularity. And that's pretty true. But actually, if you write your application well, you can have modularity without OSGi. You can, compartmentalize things neatly. But what OSGi does is OSGi enforces modularity. So it means whether you want modularity or not, you've got modularity with OSGi. And this forces you to think about it really early in your design. It means that if you cheat, OSGi will catch you and let you know. And this is really valuable. In a small system, it's maybe not valuable at all. So when you modularize Hello World, you look and you think, I've just done a great deal of effort, and all I've got at the end of it is Hello World. If you've got a big system, modularity starts to become really valuable. So what we've got a picture of here is just a bit of the JEE programming model. And it's not even into JEE yet. This is the Java SE APIs, which JEE requires. And I've only shown that bit because I couldn't actually fit any more on the slide. And even with just that bit, you probably can't read it, actually, because the resolution's pretty poor. And when you start to look at a system like this, it's almost impossible to know how these things are connected, what depends on what requires what. If I only want part of this for my web server, what bits can I safely take out? And you have a similar problem if you want to do class loading as well. If you want to find a class and you've got all of that on the class path, class loading becomes a very expensive operation. So this is an application server, but probably some of you have applications that actually look this bad as well. And management of those is really, really hard without something like OSGi. So I think, when we started out writing wars, we had this neat little war, and we had maybe 1 or 2 libraries in our lib folder, and it was pretty neat. But now we see wars that are, sometimes we see them, they're 100 megabytes, they're 200 megabytes, they're a gigabyte. And at that point, you start to think, it's no good me packaging all of this stuff into my war and carrying it around, like this massive, great big piece of luggage. You need to be able to start splitting well, first of all, you need to understand what's in that war. And second of all, you need to start being able to split some of it out. Let the server provide some of it to you. Let shared libraries or something like that provide other bits of it. And get that war a little bit more lean and mean, because at the moment, it's just too big. And some of the stuff that's in a war lib folder, you probably need. Some of it you probably don't need. But at some point you thought, I might get deployed into an environment without this library. So just to be sure, I'll just stuff it in, because it's much better, or it feels much better, to put as much as possible. It's a bit like packing to go away. You think, well, perhaps I need 6 extra pairs of shoes, because what if something comes up? So you just put them in, and it seems like a good idea, and then you realize that your suitcase is that big and you can't actually lift it, and then you realize perhaps you should have packed a bit more light. And the tools that we use really don't help with this. So, for example, when you use Maven to do your build, and it puts the Java Mail API in WebInflib, and you look and you think, I don't need the Java Mail API. Why is it in there? But part of the problem is that Maven doesn't really know whether you need it or not, so it decides to be better safe than sorry. And there's another problem with wars as well, which is that they're massive and they're really static. So if you want to change your application, perhaps you want to add a little bit to it, you need to restart the whole application. And that's slow, and that's annoying. And again, if it's a small application, not being dynamic is fine. If it's a big application, not being dynamic is a bit of a problem. So all of this so far, it's kind of an inconvenience. It's like luggage that's too heavy. You can live with it, but it's kind of annoying. But on these modern systems, we start to get a more fatal problem as well. Because we've had 10, 20 years of Java development now, and so we've had 10, 20 years of Java libraries. And so we've got, for some of the popular ones, like the logging frameworks, there's maybe 10 versions out in the field. Some of these versions are compatible with each other. Some of these versions are not compatible with each other. And if I depend on a library, and that depends on version A of my logging framework, and I also depend on another library, which depends on a different version of the same framework, if those two versions aren't compatible, or if those two requirements aren't compatible, I'm going to get some really ugly runtime catastrophes, because I can only have, my two third-party libraries, who've never even heard of each other, they have to agree on sharing the same version of their common dependency. So, what we've been doing in the Java EE space to try and get around this is we've been doing lots of crazy stuff with class loaders, and you've got your ER class loader, and then you've got your other class loader, and you try and keep them all compartmentalized. But that only works so far. And when you've just put a gigabyte of dependencies inside your war, they're going to be sharing a class loader. And so they're going to have to cooperate about what versions they need. So with OSGi, you can see it's a lot more clean. So instead of a big flat class path, where everything is just mashed together and you have to hope, the thing that ends up getting used is whatever was first on the class path. And that's not a really robust way to do it. It means, you get different behavior in different environments. Sometimes, you'll add something else to your class path, it will bring something else in, and then all of a sudden everything changes. With OSGi, the class path is much more structured. So you can see I've got my jar here. I've got these two dependencies. They each depend on a third thing at different versions. And there's actually no problem, because each of these is a class loader. And so when my jar needs classes, it looks them up. When bundle B here needs something from bundle C, it looks it up from the correct version of bundle C. Bundle A sees a different version of bundle C, and so it all just works. So this is really, it's quite clever the way it sort of naturally works. And I think this is one of the things that people really like about OSGi, is the way it sort of does this magic for you, so that you don't even see what's happening, but everything gets the dependency it wants. People sometimes say about OSGi that it makes the impossible very easy, and the easy very impossible. So this is the impossible made easy part of it. So how does this relate to you? What should you be doing when you go away? How many of you are using OSGi already? About a third, I'd say. How many of the rest of you are thinking of using OSGi? About a third as well. How many of the rest of you were thinking of using OSGi, but now after 10 minutes you've decided that that was a bad idea? That's always reassuring. So, what I was going to show, again, is the demo that will not happen. But I've got some sort of starting points as well that hopefully will be useful, even without a demo, about where you can get started. Well, the first thing is that if you're thinking of using OSGi, the path is pretty clear for you. Most of the application servers already do have support for OSGi applications, so you can go, take the application server that you're already using, and hopefully it will give you support for OSGi. The other thing that's really nice is that OSGi, it's very close to the main Java programming model. I sometimes, people will say, I've got this OSGi bundle and I need a jar. How can I convert it to a jar? Well, it is a jar. That's one of the nice things about OSGi, is a bundle is just a superset of a jar. So if you've got a bundle, you've got a jar. So here I have what I've described as an OSGi bundle, but it's also a jar. And where the magic happens is the manifest. So a normal jar, it has a file called meta-inf/manifest.inf, and it's a pretty boring file. It really doesn't have very much in it at all. What OSGi has done is they've taken that file and they've added a lot more stuff. So some of it's boilerplate, like bundle manifest version. You know, it has to be there. You will never have to care what it says. Some of it is getting a bit more interesting. So every OSGi bundle has a symbolic name, and that allows you to uniquely identify it. It also has a bundle version. And where it starts to get really interesting is with these import package and export package declarations. And so what this is doing is it's saying, I'm making my dependencies explicit. If I don't have something that provides these packages, I know I'm not going to work. So please don't even start this bundle. Don't make my classes available to other things because I know I'm broken. And this is the opposite of that. So this is saying export packages. I make this API available to other applications. If I'm started, that API is present. So far, so good. You know, if you've got a jar, then you can add a little bit of metadata and you've got a bundle. But of course, you know, we don't program very often with jars anymore. What you probably want to do is a war. The good news, though, is that a war is just a jar with a bit of extra stuff, and a bundle is just a jar with a bit of extra stuff. So you can make what's called a WAB. And a WAB is a web application bundle. And that's a bundle with a bit of extra stuff to make it into a war, or, depending on your perspective, a war with a bit of extra stuff to make it into a bundle. So both jars and wars, they've got a manifest. A jar, unlike a war, doesn't have a web descriptor, it can't have nested libraries, and it can't have non-class path resources. What Enterprise OSGi has done is it said traditionally bundles had all the same restrictions as jars, you know, so you couldn't, well, you could put other stuff in them, but it wasn't really a very popular pattern. And they've said, okay, well, let's start to make these things exactly the same as a war in layout. They can still be recognized as a bundle, but they can also be recognized as a war. And the reason this is really valuable is that wars are good. Wars make life easy. We're all used to wars. You could do web stuff in OSGi without a war, but you had to really want to. You had to, you know, wake up in the morning and say, you know what, I'm sick of JEE, I have no more JEE in my life, I'm going to do it all by hand, and I'm going to crank it, and I'm going to, you know, call to the HTTP service directly, and it wasn't nice. With wars and WABs, we've got a much more transparent programming model, which is that you take your war, you add a little bit of extra metadata, and then you fire it off into your OSGi-aware application server, and it all just works. So the things that make it a WAB rather than just a bundle is the OSGi metadata, obviously. And the next thing is this web context path header. And that just says to the OSGi framework, I expose web stuff, I'd like you to treat me as a web, I'd like you to, you know, make me available on the web. This is my context path. The other nice thing that you can do, and this is always possible with OSGi, but for wars, you know, we've said this is the pattern we're going to use, is that we're going to keep the standard war class path. So, you know, everything's going to be in webinf classes, you know, my libraries are going to be in webinf lib. I'm not going to have to try and rearrange my war to make it more like a jar so that it's more like a bundle. So this is a little piece of metadata that you can put in the header, and that says, this is my class path. It's exactly the same as a war class path. And so you can, again, you have this kind of bilingual archive that you can just use as a war, or you can use as a WAB. So this is, you can see this is what an OSGi WAB will look like. And again, it looks pretty much like a war, which makes for a boring slide, but a happy programming experience. So I've got the structure of my extra files in there is exactly the same as it would be for a war. I've got these sort of normal OSGi headers like import package, export package, And then I've got these WAB-specific headers like the web context path and the bundle class path. So far, this has been a pretty easy migration experience. You know, you've added a little bit of extra stuff to your metadata, and you now have an OSGi bundle. You may be wondering, though, what you've actually achieved by doing this, because you haven't done that much work, but you've done a little bit of work to turn your bundle into a jar, and to turn your WAR into a WAB. And the reason that we said it would be useful to use OSGi, you know, the advantages of OSGi are things like, if I have a 500 megabyte WAR, can I modularize it? And so far we haven't actually modularized it. We've just taken our 500 megabyte WAR, and now we've got a 500 megabyte WAB. But you can do better. Once you've started down this WAB path, you can then start to take advantage of what OSGi is giving you. And the first thing that I'd recommend doing is taking all of that stuff which is in your lib folder and ripping it out and putting it somewhere else. And then all of a sudden, your WAB is quite small. And if you had just a normal WAR, you could have done the same thing, right? You could have said, oh, well, I've got an SLF for J dependency, but you know, the application server is probably going to provide that. I've got another dependency, but I think I don't need that. But with a normal WAR, if you do that, you expose yourself to a terrible risk, because you may get SLF for J for free from the application server, or you may not. And if you don't, you may not discover that immediately. You may only discover it a while down the line, and then your code is innocently going along, and then it gets to the bit where it needs SLF for J, and you die with a class not found exception. And you had no way, unless you did some sort of static analysis, of knowing that you were going to hit that problem. And this is why we get wars that are so big, is because we're so terrified of hitting that problem that we just shove everything that we could possibly need in. With OSGi, because everything is explicit, you can safely take SLF for J or whatever else out of your lib folder, and then you've got this really naked little WAR. But the naked little WAR has a luggage tag on it, which says, I need SLF for J, I need this, I need that, I'm not going to be happy without them. And this means that you can run it with a lot more confidence in a lot of different environments, because you know that all these dependencies are explicit. You also get a lot of benefits in terms of your version conflicts once you start to pull things out. Because instead of having everything mashed into one WAR, and you've got 3 versions of SLF for J inside your WAR, and you're not quite sure which ones your dependencies are going to see, it's all external. Everything can be wired to the correct version of the dependency. So what do you do? Where do you get started in terms of your development environment? Or, I've sort of laid out the pattern, which is take your WAR, convert it to a WAB, make sure it still mostly works, and then rip out all the dependencies, satisfy yourself that it doesn't work because you've just ripped out all the dependencies, and then assemble the runtime environment so that it does work. There's sort of 2 schools of thoughts about OSGi manifests. I think everyone agrees that, for Hello World, you can write your manifest by hand, and that's fine. For sort of a simple demo like what I would do, I could write my manifest by hand, and that's fine. For anything more complicated, you really do need some tools to start helping you with this. So one approach says, well, the tools can help a lot. The tools can be a bit like the editor in an IDE. It will give you the syntax highlighting. It will tell you when you've got something wrong. It will give you a red underline. You can maybe do some more fancy analysis. But ultimately, it's my code, it's my manifest. I want to know what's in it. I'm going to write it. The other approach says the manifest is actually a bit more like the Java bytecode than the Java code. So you want to know it's there, but you don't want to be writing it because you're probably not smart enough to write it. So let the tools just take care of it completely. There's advantages and disadvantages to each approach. I kind of like knowing what's in my manifest. I kind of like controlling my manifest, so I prefer to write it by hand. But there's something really very nice as well about the code first approach, because what you do there is you actually almost forget you're using OSGi. You just code exactly as you normally would. The tool writes your manifest for you, and what pops out at the other end of your build is an OSGi bundle, but you didn't really have to think too hard about OSGi to get there. So if you want to use a manifest first approach, the main tool that you're probably going to be using is Eclipse PDE. Some people really love to hate Eclipse PDE. It's a slightly funny development environment for OSGi because the name stands for Plugin Development Environment. And you can see there's no bundle anywhere in there, and there's no OSGi anywhere in there. So the tool's been misappropriated a bit. It was originally intended to write extensions for Eclipse. Eclipse then converted to using OSGi. The tools went with them. But they never actually said, okay, we're going to, write the best of breed OSGi development tools. It just kind of happened by accident. So you end up with some funny things, when you're looking at the tools and it says, are you going to do a new plugin? And, here's the dependencies of your plugin. And you're sat there thinking, but I'm not writing a plugin at all. I'm writing an OSGi bundle. Please stop telling me about plugins. But if you can get over that weirdness, it is actually a very good tool. When you come to building, you've got a few choices. One thing you can do, and what a lot of people do, is they just use, ant, or, maybe a more modern build tool than ant. But you sort of, what you end up doing in your build script, which is a bit ugly, is Eclipse knows all of your dependencies. You've got your projects, they've got the dependencies on each other. It's made sure that you can't compile if you've got a dependency on something that isn't in your manifest. And then you drop down to ant to do your compilation. Ant doesn't know anything about OSGi. You reconstruct your class path, and you do this compilation which isn't actually aware of OSGi at all. And then you can end up with this horrible thing where it compiles fine, it builds fine, and then you go to test it, and you realize that actually it's not right, and you ended up compiling against things that you didn't import in your manifest. And your bundles aren't going to start, or they're going to start and, end up with a class not found exception. And, this, all of a sudden, you've done a lot of the benefits of OSGi because you didn't have OSGi in your build system. So a new project which aims to get around this is called Maven Tico. Are any of you using Tico? Two people over there. I have to say, it's not something I've used myself either. I've played around with it and I've looked and I've gone, yeah, this is really cool and this is solving a problem. And the way Tico works is it hooks into the Eclipse build, and everything Eclipse knows, Tico knows. And so it's a first-class OSGi-aware compilation. And so if you're doing OSGi development, that's really what you need. So Tico, if you want to start with your manifest, I really would recommend playing with Tico. But you may want to take the opposite approach, and you may want to say, I don't want to think about my manifests. I would like the benefits of OSGi, but I do not want to be thinking about OSGi at development time. I just want to go away, code, and then have it magically turn into OSGi at the end. And the good news about this approach is that in terms of your development, you're very free. You can choose whatever tool you like. You could use Notepad if you wanted to, and that would be fine. Or you could use, Eclipse, or you could use NetBeans or IntelliJ. It really doesn't matter because you don't need the OSGi support in your development tools. The OSGi only comes in at build time, and it comes in very late at build time. So what happens at build time is you build everything, and then you point a tool called, if you're using Maven, you use the Maven build plugin, bundle plugin. Or if you're using another tool, what you do is you take a tool called BND, and you just point it at your jars, and it goes through, it analyzes what your dependencies are, and it writes your manifests for you. I would say be careful and look at what comes out of your build system. Because otherwise you can end up with some very strange manifests, and you only discover, a year down the line, you look in your manifest and you think, why did we have a dependency on this package that none of us intended to use? And it's come through, and now you're tied to it. But it's really easy to make an OSGi bundle with Maven. All you do is you change your packaging. So instead of having a jar packaging, you say you've got a bundle packaging. You add the right bundle, the right plugin configuration somewhere in your parent POM, and you're good to go. If you want to use more of the Enterprise OSGi stuff, there are tools for that as well. So far, what I've been talking about is really just sort of vanilla OSGi. I haven't been talking about the more enterprisey programming models. But there are Eclipse tools for that. So there's one called Eclipse Libra. And there's also, IBM have one which is just free and available from the Eclipse Marketplace. And it's called the OSGi Application Development Tools. It's quite closely related to Libra. There's a cooperation going on between those two. And so if I'd been doing a demo, sob, I would have showed you the OSGi Application Development Tools. So that, again, when you convert to OSGi, it's a really smooth path at first. You've added your metadata, everything works fine, and then you've ripped your dependencies out, and this is when it starts to get a bit tricky, because you're now in the OSGi world. Everybody else isn't necessarily, and so you think one of the most popular questions on things like Stack Overflow about OSGi is, I need to get X as a bundle, where can I get it? And the answer is sometimes surprisingly easy. A lot of things that we think are jars, if you crack them open and look at the manifest, you realize actually it's already a bundle. So you're sat here with this jar going, oh, if only I had a bundle, and you do. So sometimes that makes it really easy. A lot of the software projects that are still being maintained, they have been converted to OSGi bundles. The ones that aren't being maintained anymore, it's not so easy. Those aren't necessarily bundles. But what we find as well is that sometimes you've got an older version of a library, and it's not an OSGi bundle. But if you actually just go and get the latest version, it's a bundle, and you're fine. The other thing is that someone may have already converted it into a bundle for you. And so this is called wrapping. And if you go away and you look, you can often find it. It may be that if the library you're using isn't available as a bundle, that's showing that the project isn't under active development anymore. And maybe you want to consider an alternative one, which is a bit more OSGi aware. If you really are wedded to that bundle or to that library, you can wrap your own. And so this is just a process of taking the jar, adding the OSGi metadata, and then using it. The final alternative, which sometimes has some advantages, is that you can go back and, having just ripped all of the dependencies out of your war, you can put some of them back in the webint flib folder. This has advantages and disadvantages. It means that this library isn't available for anyone else to share. But it means that the library is sharing the same class loader as your application. And depending what's going on with that library, if it needs to see your classes, if it's loading your classes reflectively, for example, because it's a logging framework, it may be that actually sharing the same class loader is the way it's going to work most easily. If you do want to look for OSGi bundles, there's a few places you can look. SpringSource have what they call the Enterprise Bundle Repository, and there's, a lot of the most popular libraries are there. You can also find a lot of them on Maven Central, but you have to be a bit sneaky about how you look. Because, of course, in Maven, every bundle's going to have a group ID and an artifact ID, and you can't have two bundles with the same version, group ID and artifact ID. So what they've done in a lot of cases is they've changed the group ID. So you have some sort of crazy group ID that you would never think to look at, but then the artifact ID is actually the same. So it's a bit annoying because you have to change your Maven files to point to some crazy group ID, but it can be quite a convenient way of getting your dependencies just from Maven in your normal build. If you want to wrap a bundle, you can use BND, which is the tool that I said, if you're doing code first development for your OSGi, that's what you'd be using anyway. So you can see it's a super painless process. It's just one Java command. You reference the BND jar in your class path, you say wrap, and then it spits out an OSGi bundle. And because they don't want to break anything, the characteristics that they have for this OSGi bundle are that it's as much as possible like a normal jar, which may be not exactly what you'd want. So it means, one of the really lovely things about OSGi is that it allows you to keep internals private. What the wrapping has done is it said every single class is externally visible, because that's how it would have been in normal Java, and they don't want to break things. Similarly, one of the nice things about OSGi is it allows you to say, okay, well, these are my dependencies, and I need them. Whereas in Java, you have no way of declaring your dependencies, and you only discover at runtime that they're missing. And so the default mode for BND, when it's wrapping, is to go with the Java mode. So it says, these are the things that you need, but you know what? You can maybe get away without them, so I'll declare them all optional. So this means that the bundle will always start, even if its dependencies aren't needed. But you can change these defaults. And so probably if you're going to wrap a jar and then share it around, it is worth making a nice clean jar. So the last option is embedding jars. As I said, if you get weird OSGi class loading visibility problems, embedding jars can be a good way around that. OSGi is one of those things, I think all the world should be using OSGi, but then sometimes you discover these libraries that are just built in a way which is so unaware of OSGi, and the things that they're doing with their class loading is so weird and so counter to OSGi that it's just not going to work. And at that point you say, okay, forget it. Let's just shove you into the bundle and pretend that you're a normal jar. The disadvantage of this, of course, is that you were trying to get your nice lean war and get all your dependencies out of it, and you've just gone back to having something slightly bloated. So the sort of one last thing. So far I've been talking about the real OSGi basics, which is the class loading, the manifests. One of the real reasons that you use OSGi is partly to get this modularity, it's partly to get this structure and this compartmentalization. But OSGi services are the other sort of mega selling point for OSGi. And what they are is they're a really, really nice solution to the factory pattern. So we've been trying to solve the factory pattern pretty much since the beginning of Java, haven't we? We came up with the factory pattern, we said, how can I get hold of an instantiation of this interface? And so we had, such and such factory, and it would use reflection. But then we said, but how do I get hold of that factory? And so then we had the factory. And I've actually seen in code bases the factory. And at this point, you know that there's something wrong with your design pattern. And so then we started doing other things. So we started doing things like meta-inf services. So, if you take your jar and you've got a folder called services inside your meta-inf folder, and in that you put the name of an implementation of an interface, then other things can look it up. And this works better than the factory, but it's still not ideal. It's not dynamic. So if halfway through you decide you want to change the implementation of that interface, you've got no hope. OSGi services are much nicer. So what OSGi gives you is it gives you a registry, and you can say, I implement this service, and you can just register with it. If you need to get an implementation of an interface, you can just ask the registry, and you can say, I would like an implementation of this. And it will just give you, the first one that it comes across. And it's really nice. But it's a little bit skilled to use the API directly. So what I would suggest is that you avoid the OSGi services API at all costs, and you use dependency injection instead. It's easier and it's more robust. And there's two main programming models here for the dependency injection. One is Blueprint, and Blueprint is based on Spring. So if you're used to Spring, Blueprint will look very familiar. the other option is declarative services. And I think declarative services definitely has the edge in terms of the name, because it does exactly what it says on the tin. It's declarative services. But both of them are very good, and both of them will make your application a lot more flexible. One of the really nice things about them is, they're dynamic. So if you add something into your application, you can start consuming its services. If it goes way out of your application, you can stop consuming those services. And this is something that you absolutely can't do with something like a factory, or the meta-inf services. So here we have the slide for the demo that doesn't happen. It's just a few closing points. I think OSGi, it sometimes has this bad reputation. We think, OSGi, it's terribly hard, it adds terrible complexity. Well, no, it really doesn't. It's actually pretty easy. But OSGi isn't magic. One of the other things I sometimes see people say about OSGi is, oh, this terrible buggy application. If only they'd used OSGi, they wouldn't have had any bugs. They would have had magic modularity. Well, no, you do still have to think about it. People sometimes say with OSGi, you can never get a no-class def found exception with OSGi. Yes, you can. If you write your manifest badly enough, you can definitely get a no-class def found with OSGi. So, you do still have to think about what you're doing and think about the modularity of your application. And if you come up with a bad modularization, OSGi will enforce that bad modularization for you. It won't turn it into a good modularization. Finally, here's a few resources. I don't think you can probably type all of those down fast enough before we leave the room, but they will be on the recorded version of the slides if you're interested. So finally, any questions? Yeah. Oh, sorry, we've got a microphone which is coming to you.
Okay, deploy question. When you have a war, it's pretty easy to say, okay, this is the application, right? But when you have a bunch of independent bundles, are there any good tools to, specify, okay, these bundles are the application and deploy them even?
Yeah, that's a really good question. Originally in the world of OSGi, there was only the bundle, and that was, your only granularity was the bundle. And it's clear that that's not good enough. And so what is coming out now is what's called OSGi subsystems. And so that gives you a lot more layers of granularity. So you can have, some of the OSGi application frameworks have had sort of a precursor to this, which they call EBAs. So that's an enterprise bundle archive. And so you can take everything, and an EBA is a bit like an ear. So you can aggregate everything into your EBA. You can either physically include them inside a zip, or you can just have a manifest and you can say, well, these are the things that make up my application. And you can also have things like composite bundles and that kind of thing. I'm afraid I've run out of time.
Time's up.
Time is up.
So thank you, Holly.
Thank you, everyone.